All right, question 15. At what point is the force on the ball equal to 0? Trick question. It's never equal to 0. There's always gravity pulling down on this baseball as it's thrown. Now, an object is placed on the planet with acceleration to gravity is 3 times that of Earth. So what's the weight compared to Earth? Well, if the acceleration due to gravity is on Earth is 10, on the new planet it's going to be 30. So what that means is when I calculate m times g on the new planet, it's clearly going to be 3 times as much. Now, here, a large truck tries to get out of the snow. We're pushing it from behind with the force F1 with this car. So we want to know how the force on the car compares to the force of the car on the truck. So again, car on truck versus truck on car. And again, this is a clear case of Newton's third law. They're equal. All right, questions 18, 19, and well, 20 we'll get to a bit, but 18 and 19 refer to the shopping cart. Let's draw the free body diagram. That's what we want. So we've got the weight, we've got a normal force, we've got a friction force, and then we're pushing down on this cart. So the diagram that most reflects that is choice D. Why? Okay, so what is the net force on the cart? And we want to know how we know this. So the cart is moving, so that rules out choice A. Now we're moving at steady speed in a straight line. That means the force is clearly balanced. So non-zero for any of these is not going to work. So that's not going to be right. And here, it actually is possible for us to determine, we know that it's balanced. So that leaves us between choice B and D. Well, we know that it is moving horizontally in the at constant velocity in the horizontal direction, and it's not moving vertically, so that leaves us choice B as the correct answer. Choice D seems like it's right, but the problem is moving horizontally means it can accelerate, so it's not as clear. Choice B is the best and clearest answer. All right, so a fly hits a truck. The fly is smushed. What happens to the truck's speed? Some of you might have been able to guess, hey, it's a fly hitting a truck, it's got to be 20, but let's actually prove it. So let's get the acceleration of the fly. That's going to be, we're going to use the velocity formula for that. So we know v equals at plus v naught. We know that the fly's final speed is 0. Its acceleration is unknown. The time it spends decelerating is 0.02 seconds, and it starts at the speed of 20. So when we actually get the acceleration, we're going to end up getting 20 divided by 0.02, which is going to be 220. 2 more zeros divided by 2. That's going to be negative 1,000 meters per second squared. Now let's get the force on the fly. So the force on the fly due to the truck is going to be m times a, which is going to be mass of the fly, which is 0.001, times negative 1,000. Remember, we're looking for the force on the fly, so we use the fly's mass. So that's negative 1 Newton. All right, now by Newton's third law, that means the force on the truck due to the fly is also 1 Newton. So let's get the acceleration of the truck. So that's going to be force divided by mass, which is because I'm using F equals ma. So that's going to be 1 Newton divided by the mass of the truck, which is 4,000, and that's going to give us like 0.0025, some ridiculously small number like that. What that means is when you can plug it into v equals at plus v naught if you really want to, but you're going to end up getting like 19.9999999. In fact, I'll just write that you like 19.99999, which is about 20 meters per second. That makes sense. You wouldn't expect the fly to have a huge effect on a truck. So that finishes up the multiple choice section, and in the next video we'll do the free response.